Permutations. It sounds like an amazing 80s band, or else the worst thing that could possibly happen to your hair. But guys, in the mathematical world, it's neither of these. It represents a very particular counting scenario that you're going to see crop up a whole bunch. Let me give you an example. Let's say that you've got 8 dinosaurs running a race, but we're only going to give medals to the top 3. So maybe we've got a gold medal, a silver medal, and a bronze. Because of that, if we want to count the number of ways this race could pan out, we're going to start with 3 dashes. One dash to represent how many options we have for the gold, another dash for silver, and the third one for bronze. And now let's plop some numbers down in those bad boys. If we're going to put a number down for the gold medal dash, it's going to be an 8. We have 8 dinosaurs, so 8 options for who can win the gold. But guys, by the time we get to the silver dash, here's what happens. We've already picked a dino to win the gold, and that means we only have 7 dinos left to possibly win the silver. And the same deal for bronze. We've already picked a gold and a silver, so we only have 6 options left for bronze. Multiply 8 times 7 times 6, and that's how many ways the race can pan out. Now guys, this is an example of a permutation. A permutation is a special counting scenario where you start with one group of people or dinos or objects or whatever, and you pick some of those things and you put them into special positions. So in the case of the dinos, we were picking from 8 dinos and putting some of them into the special positions of gold winner or silver winner or bronze winner. In this particular case, you would write this as P of 8, 3. Whenever you write a permutation this way, it's shorthand for the number that you're trying to find. And the first number means how many options you start with. In this case, we have 8 because of 8 dinos. And the second number means how many special positions you have that you're going to be selecting for. So we have 3 because gold, silver, and bronze. Here's another example. Let's say that you have, 10 people, and you're going to select from these 10 people someone to be president, someone to be vice president, someone to be secretary, and someone to be treasurer. If you wanted to write the number of ways you could select all these positions out, you would start by writing this as P of 10, 4. 10 because we have 10 people, and 4 because we have 4 special positions that we're going to be selecting for. If you actually wanted to compute the correct number answer, then you could go ahead and draw 4 dashes. 4 dashes because we have 4 special positions, and if you want to, you could even label them President, VP, Secretary, Treasurer. And in those 4 positions, then you would do this descending number pattern that we remember from the dinosaurs. 10 options for president, and that means we only have 9 people left to be vice president, 8 for secretary, and 7 for treasurer. Multiply 10 times 9 times 8 times 7, and that's how many different ways we can fill these cabinet positions. Now guys, one last word to the wise. There is actually a formula for how to compute the numerical value of a permutation. That way, if you're asked to compute, let's say, P of 6, 2, you don't have to write out dashes if you don't want to. Here's the formula, and if we're going to use it to compute P of 6, 2, we're just going to plug in 6 for the top number, 2 for the bottom number, and that means we're going to have 6 factorial on top, 4 factorial on bottom, and if you cancel those the way you might remember how to do with factorials, then you're going to get 6 times 5, which is 30. No